Hey there students, Mr. Cutie here. In our video today, we're going to be looking at one of the problems from our homework assignments dealing with power. So this is coming from Quest Homework 7B. Depending on the year you're watching this video, the numbering system may have changed just a little bit, but this is going to be a question involving power. As always with these videos, I'm going to read through my version of the problem, so the problem will have the same concept but different values that you'll look at. So here, this is a problem involving an air compressor. It says this: a small air compressor operates on a 1.1 HP or 1.1 horsepower electric motor for 9 hours. And it does give us and the question we're looking for is how much energy is consumed by the motor daily. 1 horsepower equals about 750 watts. Okay, so here's what we're given here. We're given the power of our motor, which is 1.1 horsepower HP. Now it does give us a conversion from horsepower to watts, so I'm going to go ahead and make that conversion real quick. 1 horsepower is equal to 750 watts. So I'm going to go ahead and make this conversion right off the bat. So 750 by 1.1. So here our power is 825 watts. Okay. Okay, so it says here, how much energy is consumed by the motor daily? Okay, so daily, 9.4 hours. Okay, so we're told that the small air compressor operates electric motor for 9.4 hours a day. So our time here is 9.4 hours. Now, one of the things we want to watch for is this. In this problem, we are given 825 watts. Remember, a watt is 825 joules per second. So one thing we want to pay attention to is, well, that time is in hours, but our power is in joules per second, so we want to make sure our time units agree. So I'm going to go ahead here, do this in a different color to give some contrast. Time of 9.4 hours. I'm going to go ahead and make a conversion from hours over to seconds. That way I can use the time in the appropriate unit. So I've got 9.4 hours. That's going to be 1 hour to 60 minutes. And then 1 minute to 60 seconds. If you maybe know top of your head that 1 hour is 3,600 seconds, you can use that as well. And I've got 9.4 by 60 by 60, so I'm going to multiply my values in the numerator and then divide by what's in my denominator. Those are just 1, so I won't have to worry about that too much. So I get 33,840 seconds. And that is the time that the motor is running in 1 day. Okay, so the question is, how much energy is consumed by the motor daily? Now we have the power and we have the time, so here's what we can do. Remember that power is a ratio of work done over time. Now work is also a change in energy. So power is equal to a change in energy over time. So the question is asking how much power is consumed by the motor, so how much energy is consumed by the motor, my apologies. How much energy is consumed? How much is our energy changing when the motor is running for 1 day? So really what we're looking for here is this term, delta E. Now I'm going to rearrange my equation here. I've got power is delta E over time. So I'm going to multiply that by time. And time will cancel out. So here's what I get. My change in energy is equal to the amount of power my motor contains, which we found that earlier, 825 watts, multiplied by the time that the motor is running. And again, don't be too confused there. It says how much energy is consumed by the motor daily. I'm not looking at one entire day. I'm looking at the time it runs during a day. And my time is 9.4 hours. So we want to make sure we pay attention to that time. So I've got my change in energy. That's what I'm looking for. How much energy is being consumed, how much is our energy changing, is equal to power, 825 watts, or that would be joules per second, multiplied by, what was my time, 33,840. The board takes a moment. 840 seconds. And I should now be able to multiply the power from my motor, multiplied by the time the motor is running, to get what I'm looking for. So I've got 825 multiplied by 33,840. I get a relatively large number here, 27918 That would be in joules. Now, I want to make sure I know what units it's wanting. It does say answer in units of J, so answer in units of joules. So I could just type this number in if I wanted to. That would be 27,918,000. I could also put this in scientific notation if I would like. And that would be 1, 2, 3, 4, 5, 6, 7. So I can also write this as 2.79 e to the 7th joules. And I can type that in on Quest as well. Okay, so here's how we would solve the first part of our question. Right? How much energy is being consumed? What's our change in energy as the motor is running for 9.4 hours in one day? Now, there's a second part to this question, and this involves doing a bit of a cost analysis. We've touched on a few things related to cost, but I want to make sure we have some clarity on what we're doing here. So the next part of the question says this. If electricity costs 20 cents per kilowatt hour, how much does it cost to run the compressor each day? Okay, answer in units of cents. So I want to be mindful of that. Okay, so here's what it tells us. And I'm going to come over to kind of a new part of this. It tells us that our energy is rated, or electricity costs 20 cents. So I'm going to go 20 here. 20 cents per kilowatt hour. Right? And that's an important value that we have. Now again, your number will likely be a little bit different. This is the number I'm given, 20 cents per kilowatt hour. Now, in order to find, the total cost, we need to know how many kilowatts, what's our power, and how many hours, what's our time, right? What's the power our motor is using, and then how long is that motor running for? Now, we actually know what those values are. Our power is 825 watts. We found that from the previous part, right? 1.1 horsepower. 1 horsepower is 750 watts. We did some unit converting there. And our time, we were told, I believe, was 9.4 hours. Now, I'm going to leave that time. Last time, in the first part of the problem, I converted that to seconds because I was looking for how much energy the motor was consuming. Now, because our cost is assessed as a cents per kilowatt hour, I want to make sure my time is in hours so it aligns with what my rate here is. This is what we call the rate that we're paying, the amount we pay per the energy we're using. Okay. So I want to find my kilowatt hours. So I'm going to take, this is actually, to be specific here, this is actually a measurement of energy because we're going to take power times time. So our energy here is equal to power, times time, actually our change in energy. Kind of the same equation we used earlier. And our change in energy, how much energy we're using, is 825. Ooh, it does say kilowatts, so I want to pay attention to that. So this would actually be, if I divide by 1,000, 0.825 kilowatts. Just converted from watts to kilowatts, divided by 1,000. So we get 0.825 kilowatts multiplied by 9.4 hours. Okay? So once I'm here, I will then take 0.825 multiplied by 9.4, and I get delta E, my change in energy, how much energy we're using, 7.755 kilowatt hours. Okay, so now that I have that, I know that I'm paying 20 cents per every 1 kilowatt hour. This is basically saying 20 cents over 1 kilowatt hour. But I'm using 7.755 kilowatt hours. So I'm going to pay 20 cents for every one of these. I need to multiply 20 cents by how many kilowatt hours I'm using, or how much energy I'm using. Usually we express energy in joules. This is just kind of another way we can express energy. The power we use times the time we're using that power. So to find my answer here, to find my cost, I'm going to take my rate and I'm going to multiply by my change in energy. Okay, so this is going to be 20 cents per 1 kilowatt hour multiplied by 7.755 kilowatt hours. Right? And now I'll just take 20 cents multiplied by 7.755 and I get 155.1 cents. And that would be my answer here for the second part, right? We're given a rate, 20 cents for every 1 kilowatt hour. We need to figure out how many kilowatt hours we use and then multiply our rate by how much energy we use. Okay, so hopefully that gets us going on this question here on the homework. And as always, if you have other questions, make sure to let me know, reach out. You're welcome to stop the video, pause it, rewind as you need. Again, your numbers will look a little bit different here, but this is kind of an extension, an application of what we're doing with power. So as always, hopefully this gets you going in the right direction. And please let me know if you have any questions, and good luck.